Hi there, I'm Dr. Chris. In this video I'm going to talk to you about the 5 fundamental geological controls that are required for hydrocarbons to be found. These controls include a source rock, which is geologically time and depth dependent, a reservoir rock for storing those hydrocarbons, a migration path for the hydrocarbons to move from the source rock to the reservoir rock, a trapping mechanism which can be structural, stratigraphical, or a combination of the two, and finally a seal to prevent further migration of the hydrocarbons. Here we go. Let us look at a simple cross-section of the Earth which reveals layers of rock that have been deposited over time. In an ideal situation, we will have a source rock with a very large volume. This source rock, or as one of my mentors called it, the kitchen, might be a shale from an ancient landlocked sea or a deltaic environment. It will be rich in organic remains which will determine which type of hydrocarbons are present. We'll also have a migration path, in this case a porous layer, for the hydrocarbons to migrate through. This path can also have structural characteristics like tilt, which I will show later. Next will be a reservoir rock, possibly a sandstone deposited as an ancient sea advanced and retreated over time. And at the top, a cap rock, which is impermeable and unfractured, once again possibly a shale deposited as an ancient sea retreated. However, this flat cross-section is unlikely as the Earth compresses and folds over time, producing, in this case, 2 anticlinal structures which reveal the last features for hydrocarbons to be found, a trap or trapping mechanism. With these features intact, we will be able to use geophysical techniques to identify each feature and build a story which will aid us in exploring for hydrocarbons. The story will include the source rock, which should be deposited at the proper time and be at proper depth for hydrocarbons to be created. A migration path, in this case a permeable or former permeable rock or path for the hydrocarbons to migrate. We want to tell a story about the reservoir rock, which needs to be porous to store hydrocarbons in mass quantities. We also want to make sure that the cap rock is impermeable and unbroken to stop the hydrocarbons from migrating out of the traps. There are also some other features of these characteristics which we are also very interested in, such as the thickness of the source rock to ensure that enough hydrocarbons have been created, the thickness of the reservoir rock to know how much hydrocarbons we can acquire. We want to know what type of organic material was present at the time of deposition, marine organics for oil, and plant organics for gas. Further, hydrocarbon types are also based on depth and temperature. If the source rocks are shallow and cooked at moderate temperature, oil will be produced. If the source rock is deep and at high temperature, gas should be produced. Or there's always the possibility that both oil and gas are present in the reservoirs. We also want to know the maximum extent of the trap, which is called the spill point, where the hydrocarbons will pour out of. We also want to know how much oil and gas are possible by looking at what is called the closure, from the highest point in the trap to the spill point. The depth is important, so we know how deep we have to drill to find the hydrocarbons. We also want to know about fractures. In this case, fracturing only affects the reservoir and migration path. Hydrocarbons can migrate from the source rock through the migration path and still accumulate under the impermeable cap rock. The increase in porosity of the reservoir from fracturing could even mean more hydrocarbons. However, if fractures break up the cap rock, any hydrocarbons can easily escape, leaving the reservoir empty. In this case, the hydrocarbons move from the source rock to the migration path and continue through the fractured cap rock, leaving no accumulated hydrocarbons. There could also be faulting within these structures. In this case, there are 2 faults, one advantageous for hydrocarbon accumulation and one which allows the hydrocarbons to escape. On the right, the faulting has moved the cap rock, but a seal still remains, allowing hydrocarbons to accumulate. On the left, the seal is broken and the hydrocarbons can escape with no hydrocarbon accumulation. This faulting brings up an important concept of timing of the geological structures. This layering was originally laid down flat, but if the layers tilt, the petroleum still has a source rock, a reservoir rock, and a cap rock, but the tilted migration path allows the hydrocarbons to flow up and away. Even after folding, we still have a source rock, an alleged migration path, a reservoir and cap rock, and an anticlinal trapping mechanism. However, during the previous tilting process, all hydrocarbons have migrated away, leaving the reservoir filled with water or nothing at all. This shows the importance that timing has for our features for hydrocarbon accumulation. To recap, there are 5 fundamental geological features that are required for hydrocarbons to be found. These features include a source rock, where organic material and sedimentary basins are buried and cooked over time into hydrocarbons. A reservoir rock, which is porous enough to store those hydrocarbons. A migration path for the hydrocarbons to move from the source rock to the reservoir rock. A trapping mechanism, which can be stratigraphical, structural, or a combination of the two. And finally, a seal to prevent further migration of the hydrocarbons. I have my notes down below to click on if you like. If you liked my video, please subscribe to my channel and give me a big thumbs up. Till next time, I'm Dr. Chris, and keep rocking.